So, we've all seen this massive explosion of generative AI tools, right? But how do they actually work? And maybe more importantly, where's the real value in this brand new economy? Well, today we're going to pull back the curtain and demystify the tech that's changing our world, from the core models all the way to the products we're using every single day. Since about 2022, we have been living through a financial gold rush of, truly historic proportions. Just look at these numbers. Microsoft has more than doubled its valuation. Google's grown 2.5 times over. And NVIDIA, the company making the chips that power this whole thing, has seen its value explode by a staggering 10 times. This is not just some gradual growth. It is a fundamental, seismic shift, and it is all being driven by Gen AI. Now, of course, whenever you see growth this fast, the big question always comes up. Is this for real, or is it just another tech bubble? We've seen hype cycles before, right? Think about things like blockchain or NFTs. They were all over the news, but they never really became part of our daily lives. But here's the difference with AI. Chances are, many of us have a ChatGPT or Gemini tab open right now. This technology isn't just hype, it's already proving to be genuinely incredibly useful. So here's how we're going to break it all down. We're going to start with that financial gold rush we're seeing, then dive into the brain behind it all, the large language model. We'll look at how it learns, how it gets put to work in the real world, and finally, where you might actually fit into this whole new ecosystem. Okay, let's get right to the core of it. The engine that's driving this entire revolution is a piece of tech called a large language model, or what you'll always hear people call an LLM. So, what is it? Well, technically, it's a kind of neural network. The easiest way to think about it is like a super complex algorithm that's been fed a gigantic library of text. I'm talking books, articles, websites, basically a massive chunk of the entire internet. And just by processing all of that data, it learns the patterns, the grammar, and all the weird relationships in human language. But if you boil it all down to its absolute most basic function, what an LLM really does is predict the next most likely word in a sentence. It's that simple. You give it a phrase like, "the sky is," and its entire goal is to calculate the most probable word that comes next, which is almost certainly blue. It just does this over and over, one word at a time, to build everything from a simple sentence to a really complex essay. So that's the big question, right? How does it get so incredibly good at predicting what comes next? How does it learn? Well, this whole process is fascinating, and it actually scales up from a concept that, believe it or not, we all learned back in school. First things first, we got to talk about something called a token. See, computers don't read words like hello, they only process numbers. So the very first step is always to break down text into these little numerical pieces called tokens. You can think of them as the basic building blocks of language for a machine. And as a general rule of thumb, 2 English words usually break down into about 3 tokens. Let's just use a simple sentence to see exactly how this works. So here, each word in our sentence gets converted into its own unique number, a token ID. He becomes 123, lives becomes 456, and so on. This sequence of numbers, this is the language that the machine actually understands. Now, what's really cool is how the actual learning happens. And to wrap our heads around it, we're going to use an analogy with a very simple equation that most of us probably haven't thought about in years. Remember this? Yeah, the equation for a straight line. It might seem super basic, but the principle at work here is exactly the same one that's inside a multi-billion-dollar AI model. Okay, so in this equation, x is our input, what we already know. Y is the output, what we're trying to predict. But the real magic is in M and C. These are the parameters. They're the secret values that the model needs to learn. And how does it learn them? By looking at tons and tons of training data, which are just examples where we already know both the X and the Y. If it sees enough examples, it can start to figure out the right values for M and C. Now, let's just scale that way, way up. An LLM is fundamentally the same idea. It's just an unbelievably complex equation. But instead of only 2 parameters like M and C, it has billions of them. And to figure out the correct values for all those billions of parameters, it needs a colossal amount of training data, which is exactly why they feed it huge portions of the internet. And this learning all happens in a constant feedback loop. The model gets an input, like the first few words of a sentence, it predicts the next token, then it compares its guess to the actual next token from its training data. It measures how wrong it was. That value is called loss, and it uses that feedback to slightly adjust its billions of parameters. Now just repeat that process trillions of times, and you get a model that's freakishly good at predicting the next word. So that's the theory, but how do we take this amazing next word predictor and actually turn it into a product that can, say, summarize your meetings for you? Let's look at how this technology gets built into something really useful. An AI meeting assistant is a perfect example of how different AI parts are all orchestrated together. It's not just one LLM. First, it captures the audio. Then it uses a specialized model like OpenAI's Whisper just to transcribe that audio into text. But here's the key step. It combines that raw transcript with a really carefully written system prompt. Basically, a set of instructions telling the LLM how to behave, like you are an expert note-taker. It then sends both the transcript and the prompt to a powerful LLM, which then follows those instructions to generate a perfect summary. Okay, but this brings up a huge challenge. A standard LLM only knows what it was trained on from the public internet, right? It knows all about Shakespeare, but it knows nothing about the marketing report you wrote last week. So how do you make it smart about your specific private data without having to retrain the entire model from scratch? The solution is this incredibly clever technique called RAG, which stands for Retrieval Augmented Generation. This is basically the secret sauce behind so many of the AI products you see that can talk to your personal data. It's a way of feeding the LLM just the right information at just the right moment. The RAG process is honestly brilliant. First, you take all your private documents and break them into smaller chunks. You convert each of those chunks into a numerical representation called an embedding, and you store them in a special database. Now, when a user asks a question, the system finds the most relevant chunks of text from your documents and hands only those chunks, along with the original question, to the LLM. The LLM then uses that specific provided context to generate a highly relevant and accurate answer. Andrej Karpathy, who's one of the leading minds in AI, he puts it perfectly. Techniques like RAG are all part of something called context engineering. It's not just about having a powerful model, it's about the skill of providing that model with exactly the right information at exactly the right time to get the best possible result. All right, so now that we've got a handle on the technology, let's zoom out and look at the business side of things. Where are the actual opportunities, and how does this whole ecosystem really fit together? You can think of the Gen AI world as a 4-layer stack. Right at the bottom, you've got infrastructure. These are the companies like NVIDIA that provide the raw computing power. Above that, you have the model creators like OpenAI and Google. And then you get to the application layer, where products are built on top of these models. And finally, the services layer, which is all about using these new tools for clients. For most people, the single biggest opportunity is right there in the application layer. So, this is the crucial takeaway. You don't need to build a foundational model from scratch or a giant GPU farm to be a part of this revolution. The real frontier is in the creative application of these incredibly powerful tools to solve real-world problems. You now understand how the engine works, so the only question left is, what are you going to build with it?
If you enjoyed this video and found it helpful, don't forget to like, comment, and share it, with others who might benefit too. To learn more about product management and digital marketing, make sure to subscribe and hit the bell icon so you never miss an update.